All right, 7.2, drop some more. The table and graph show a more complete picture of the temperature changes on the same winter day. The function T gives the temperature in degrees Fahrenheit h hours since noon. So if it's 0 hours since noon, that'll be like 12 p.m., 1 p.m., 2 p.m., 3 p.m., all the way down to midnight. All right, so they want us to find some more average rate of change. And the reason they say average rate of change is because there are several rates of change. I could draw a line connecting this dot to this dot to that dot. They would all have different rates of change. So what we're trying to do is find out between all of those rates of change, what's the average of them all? What is the one that is sort of a combination of all different rates of change? So we want to find the rate of change between noon and 1 p.m. So I'm looking at these two coordinates here. So between noon and 1 p.m., that's a change of 1 in x, and also a change of 1 in y. So a change of y or a change of x is equal to 1 over 1, or just 1. All right, explain or show your reasoning. We just showed our reasoning right there. Between noon and 4 p.m. So now we're going between 0 and 4, 18, and 25. So that would be plus 4 here. And 18 to 25 would be up 7. So change in y over change in x is equal to 7 over 4. Because we're talking about degrees, really, it's easier to talk about degrees and decimals, so I'll convert this to 1.75. You can also get that if you divide 7 by 4 in your calculator, if you can't do that conversion in your head, which I don't expect any of you to. All right, between noon and midnight. All right, so that's from the very beginning till the very end. And what you notice at the beginning, between noon and 1 p.m. and noon and 4, we're going up, right? We're increasing. But if I'm starting here and ending there, I should expect to have a negative rate of change. Because if we see it dropped pretty dramatically after 4 p.m., which makes sense on most days of the year. It gets colder after the afternoon, going into night when the sun goes down. All right, so if I'm looking at my coordinates, I'm going to stack them just because they're so far apart. I'm going to put 0, 18, that's for noon, and then midnight is 12, 7. So my change in x is plus 12. My change in y is minus 11. So that would be a change in y over change in x, or negative 11 over 12. I cannot do this in my head, so I'm going to pull out my calculator. All right, negative 11 over 12. And that is a rational number since it's a repeating decimal. You see a 7 there, but it's really just rounded because there's so many 6s that they're rounding the last one up to a 7. So that's equal to negative 0.91, and that 6 is the only part that's repeating, so I'm only going to put a bar over the 6. All right. Remember my and Tyler's disagreement? Use average rate of change to show which time period 4 to 6 p.m. or 6 to 10 p.m. experience a faster temperature drop. Well, we already did that. You can see our work here. We showed the exact rate of change. I imagine for this do now, if we had been in class, it would have been more like argue which one you think is more, and not have such a formal math. But since I'm doing the work, this is how I would have done it. I would have calculated everything. All right. Good. So that's 7.2. Are you ready for more? Over what time interval did the temperature decrease the most rapidly? All right, so if I'm looking at my grid, I'm really looking for the slope that looks like it is the steepest. And if I were to take a guess, I would guess that the steepest slope looks like it's right between here and here. So I would say between, that looks like 5 and 6 p.m. All right, when did it increase the most rapidly? Again, I'm looking for the steepest, now positive slope. So if I look at my graph, I would say that this looks to be the steepest right here. And if I really wanted to, I could sort of connect these dots to get a better idea. If I'm looking at all the positive slopes here, I would definitely say that this one is the steepest, and that's between 3 and 4 p.m. All right, so that's all for 7.2.